so that we must make y the subject of the formula so that we can find our gradient. So what we are doing here now, you don't have to do it for the assignment because y is already the subject, but for the example I made, just increase the level of difficulty a little bit. We have to make y the subject of the formula. Please help me out. Can anybody tell me what do we do now?
So we cancel 12x by putting a minus 12 there.
Putting a minus 12x on the left. If we put a minus 12x on the left, what do we have to do?
Bring the minus 12 on the side.
Put a minus 12x on the right.
And we cancel that positive. I think that negative 5 by adding 5. And we add the 5 over there.
And we add the 5 over there, meaning on the left side.
Yeah.
So in our next step, what do you say right there in the next step?
3y is equal to negative 12x plus 5.
Okay. And this, what I'm doing there now, you all have it already, you know, from since day one, since the beginning of the semester is in the explanation. So what I did now, I said, well, okay, let me try a different technique. I took it and I erased, and then we are doing it again. So you can follow with it. I sent it on the group chat so you can follow with it. Okay. So therefore now, what are we to do now? We are making y the subject of the formula. What to do?
So we're going to cancel that 3 there.
We're going to cancel that 3 by dividing by 3.
And divide by 3 all on the other side.
Okay, so divide it piece by piece, because it's a gradient we're looking for, isn't that so? So don't just put one long line and put a 3 under the long line. Piece by piece, because it's the gradient we are searching for. The whole idea we are rearranging is to find M1. So the 3 cancels out. And then what are we left with?
4 y is equal to 4 negative. Okay, that's really negative. By the way, negative 4 plus 513.
Exactly. Y is equal to negative 4x plus 513. So then let's come down a little bit. So what can I say? Therefore what?
M1 is equal to 4.
M1 is equal to 4.
Negative 4, because the example of an error, the example
right. Be very careful. Don't forget the negative sign here. Alright, it comes with the 4. It's describing the 4. What kind of a 4? A negative 4. It's like an adjective. So M1 is equal to negative 4. No, let's continue. I put some blank spaces there. Let me help it fill in the blanks. To find M2 now, because it's another line we're trying to find. Since the two lines are what?
Parallel.
Ah, someone said parallel. Do anybody want to agree?
Perpendicular.
Or different?
Oh, Lord Jesus.
Perpendicular. Okay. So we're on perpendicular now. Since the two lines are perpendicular, okay, let me just copy this there just to show you we are being guided from the question. Okay, so I'm just copying this there. Since the two lines are perpendicular, what can we say? Are their gradients equal? But that is where I realize, right? That's where I realize some person normally
gradients are negative inverse to each other.
Gradients are negative inverse. Okay, it's a little bit trickier than the parallel. So try to get accustomed to it. Negative inverse. No, that is the idea. I've been looking at some videos of how to learn. New information, don't treat it like it's a burden. Treat it like a challenge. Alright, and then you're going to overcome it, and that is how you climb up the ladder. So new information, new things, don't treat it like a burden. Treat it like a challenge, and a curiosity to learn something new. So I know Sometimes this area normally gives persons a little headache, but treat it as a challenge. Negative inverse, that's a word or two words. What does that mean algebraically? Negative inverse. Let's go to the notes why I call it negative inverse. Negative is a negative sign. Inverse is 1 over.
1 over.
Negative inverse.
So see,
Negative
my PowerPoint is
inverse.
already a negative. It says negative 1/4, right?
Okay, so look at what we're going to do. Keep that thought. Keep that thought. No, I'm going to put, okay, oh, negative inverse. Yeah, look at what I'm going to do. All right. So based on what you all are telling me, it helping me add new stuff to this. That's why I normally say this approach normally has, apart from the hiccups of the technology, it has some advantages to it. So
And
you
this
have
is
no
negative.
fear I'm going to erase the board and you miss out. So just make sure that you take down little notes. Now, what does negative inverse mean symbolically? Because that's what math does, change words to symbols. ONE, you have a line. Equal, you have two parallel lines. Okay? Negative inverse. So the negative is a dash and inverse is 1 over.
Negative over.
All right? The first one. Okay, so you'll have a first equation, you'll have a first gradient already, sorry. So to find the other gradient, if they are perpendicular, is negative 1 over the first one you had. What is the first gradient we have?
-4.
We have a negative 4. And to find negative 2, we have to do that. We have to do a negative 1 inverse. How do we do a negative 1 inverse? Okay,
-1.
let me take this there, copy this. See, all this you can do with, that's why it has a little
Keep saying.
positives in it. So we're going to do a negative 1 inverse. So let me take this out. So what do you think I should write after that equal sign?
1 and 1.
What comes directly after the equal sign? Let's
A
go step
negative
by
sign.
step. A negative sign. So you have a negative
Negative.
sign there, you have a negative sign there. And then a fraction.
1 over something.
1 over something. Normally is wise to use brackets. 1 over something. You're going to put something in a cup. You're going to put something in a basket. 1 over something. What comes in that basket? M1, right? M1.
1.
And what is M1?
4.
-4.
Negative 4. Okay. So please, well, you have the privilege of replaying the video again. Okay, so we can move on. Okay, so it's negative 1 over whatever you have. You have a negative 4 is 1 over the negative 4. Remember, it comes with a negative sign, negative inverse. And a little bit of simplification. What's a negative divided by a negative?
Positive.
Positive. So your new gradient is a quarter. All right, your new gradient
So,
is a quarter.
Mr. Gael,
Yes.
so the word in that case then, the word inverse means literal sense.
1 over. In maths, once you hear inverse, just think of 1 over.
But you can just turn it positive, right?
No, no, no. Inverse doesn't mean turn positive.
No, you
Inverse,
just turn it positive.
because a negative divided by a negative is a positive. Let me write it down there. That's why it come positive. Let me write it down there. Take note. That's why I normally say this is a language. Things builds up. All right. What we're doing is based on prior knowledge. All right. A negative divided. You have heard that before, right?
Mm-hmm.
By a negative is a what?
Positive. A
Positive.
negative and a negative is a positive.
So that is why this becomes a positive 4, not because of the word inverse.
No, but I know the word inverse is opposite. The word inverse itself
Is 1 over. In mathematics, it means 1 over.
is
Please
that.
write this down. In algebra, inverse means
Okay.
1 over.
And I see it says positive. That's why I asked you if it means literal sense.
Well, the reason why this turns positive is because of that. A negative divided by a negative. Here you have a negative
Okay.
1. You don't see the 1, but there's a 1. There's a negative
I
1.
know. I know.
And divided by a
Okay.
negative 4 is a positive.
Positive. Okay.
So that's why we have the
Yeah.
positive, not because of the word inverse.
Okay.
The inverse is the 1 over.
And this is inverse of each order. Okay.
Right, well, just take note of that because you might have your notion of what inverse means. You see,
Okay.
you like opposite, but
Mm-hmm.
right, but in algebras, most times, yeah, just take note for this course particularly. Take
Okay.
note of that. Once you hear inverse, 1 over.
Okay.
Okay. Inverse might mean something else somewhere else, all right?
Okay.
In this course, college algebra 1, coordinate geometry,
It's
inverse
one
means
over.
1 over. So take note of that. Okay. Right. So we have our quarter, and then we have just found m. We have